not a great idea because we need to do this week's lecture. So yeah, we have two topics, which are functions and pseudocode. So like half of the lecture will be on functions, I guess, maybe not exactly half, but sort of about half of it will be on functions. And then we'll start with a new topic, which is pseudocode. So two topics for tonight. So this little slide just gives us a review, I guess, of what we've been talking about. The idea of program structures, and that's going to come up in the quiz, right? We saw that's one of the main things in the quiz. We've got these three program structures that we're kind of familiar with now. The idea of sequence, where, you know, one line of code, then the next line of code, the way that they are represented on a page when you're entering it into your editor, that's the way they will be processed by the computer program. And that's because of remember the fetch, decode, execute cycle. What happens is it retrieves one instruction into the memory, and then it decodes it and processes it, and then it retrieves the next. So they must be in order. Then the other sort of thing, isn't mentioned in using the words that we've used, but conditionals go with selection. Selection, that's our if then else. That's another word we use for it is branching. We branching like a tree. We can go one direction or another. Maybe you remember some of those diagrams that were in some previous lecture. And then lastly, a kind of a type of branching, and it can be constructed using branching tools, is the loop. But we will use while some condition, we will do this stuff. And hopefully you're nice and familiar with those things now. So the topic here about functions, you may have heard the word functions used in connection with your mathematics study at high school or even here at the college, because I think you had to do some mathematics here at the college. So you probably process some functions for pre-calculus or whatever, right? We typically use it for graphing things and stuff like that, right? So you'll do something like this. You can take a function like this and substitute a value in for the x and y's, and based on that, you can come up with some result for the function. So for example, for the function fx is equal to x squared plus 1, you can substitute 0 as a value for x. And then your function, where x is 0, is 1, right? Because 0 squared is 0 plus 1, that's 1. And if you put the number minus 1, that would be a strange one, right? You put a minus 1 into a function and process minus 1, what kind of result would you get? Well, in fact, you'd get minus 1 squared is 1, right? Because when you multiply a minus by a minus, you get a plus. Anyways, I didn't want this to be a math lesson, but the thing is, I'm sure that you could sort of do just what I've been talking about. That's something that's familiar to you. Some could be a little bit more complex. Like here, we've got two. For the G function processes two parameters. We will use that word for them in functions that we have here in our programming, parameters. We could also use the word arguments. They are the inputs. Okay, so our parameters are our arguments for our functions. They become the inputs. So we input some value for x and some value for y. Again, x and y could both be 0, in which case this would just be a value of 2, because these zeros, 1 plus 2 would be 3, right? But then, you know, you could put all kinds of other numbers. And as I said, I won't do the math on that. You could have a lot of fun with that. In programming, we would typically use a function. A function is going to be a subroutine. It's going to be something that's going to be repeated. So we go to the trouble to actually make the function. It's going to be something that we're going to use maybe as a general purpose, a little routine that's going to be called whenever it's needed. And we're going to input some values into it and expect some output from it. So as it says, we put some values in, we expect an output from it. It's going to have a unique name. Now, if it's a really, really good function, I mean, some computer programmers that are really excellent sort of at their craft, I guess you could say, they'll be writing functions. They'll say, hey, that took me a couple of days to get that function going. It's a pretty good function. Why don't I put it into a library where other people can use it and save themselves some time? Or at least I can use it so I don't have to reinvent the wheel, right? Whenever I want to use that function, I've got that function available in a library. So that's an important point about functions, is we often want to use them in another context, or we want somebody else to be able to use them. And so we will put them into a library. We'll talk about that in a minute. Now, on our flow chart, we represent a function looks like a looks like a process, doesn't it? But there's one thing that makes it just a little bit different than a process. And maybe you can see that double line on the edges. So it's got a rectangular box like a process, and a function can be treated like a process in a flowchart. But the double lines means that somewhere else in our flowchart, probably, we've got some description of this function, but it is a function. There's more inside there, okay? This box is actually containing a lot of code, probably. It's not just, you know, what we're showing is just the name of it, but there's a lot happening inside there. There's a function with some processing happening inside. So taking a simple example, the example being we take three numbers, these three numbers in the specific case. Now, you know that you like to do abstraction, right? Abstraction is part of our computational thinking. We want to be computational thinking. That was really part of this course. Abstraction, we would try and get this down to the most general case. Remember that in the tests that you were doing? We had the specific case and the general case. This is actually kind of a very specific case. We got the specific value of an assignment grade, the specific value of a quiz grade, and the specific value of a test grade. But if we wanted a really general value for each of them, we would just say grade 1, grade 2, grade 3, or something like that. Or you'll see as in a few minutes that we'll just do X, Y, and Z. Very, very general. That way we could use them for many other general purpose activities instead of just having to be about an assignment, a quiz, and a test. So we've got some inputs here. I hope that you recognize those input symbols. And we've got a couple of little processes that are dependent on the inputs, right? These processes won't happen unless those inputs are there. We've got the sum, we need the total of each of those three inputs. And then we have another value where we take the value that comes out of that process and we divide it by 3, and that gives us another value. Then we output the return. Now, so what we got, inputs and then two different processings. This would be ideal for making a function, because your function is going to do that, take some inputs, process, and then some output. Oh, this could work here, right? We could turn this into a function. Let's see. Well, we actually do this in the next slide. So what we see happening is we say, okay, we got those inputs. Those inputs are going to go into this function. They're going to go into this function. And then once that function is completed its process, it's going to output the overall. And so we see that here. We see the way that we're doing it. We've got actually two flowcharts now. We got a flowchart just for the function, and we got a flowchart for the overall program, which includes the function as using the function symbol. And this basically says there's a function that does this. So you would go and look somewhere on another flowchart. Well, it just happens to be beside here now. And we would look for this process. And and there it is. There's our function. Now notice here that the function is average grade X, Y, Z. Here, when we call, in the main program, it says average grade assignment quiz test. Now this has to do with the abstraction that I was talking to you about a minute ago, right? What we're doing is we're extracting it down to the most general case. In other words, for this function to work, it doesn't care which one is, or the person. So computers don't care. Well, that we just take that for granted, right? But the person who is using this program, the way they're implementing it, they don't care if the numbers are assignments, quizzes, and grades. When they use this, they will decide what X, Y, and Z is, right? It may be that it'll be assignments, quizzes, and grade. If it's called from this program, yeah, there'll be assignment, quizzes, and grade. But they might be called from another program. We could use this function in a general case. We could use it for any three numbers we wanted. I hope you can see that, right? We have abstracted it so we could use it for any three numbers. So how does this work? Basically, it just says three numbers are input, and then those three numbers are added together, 1, 2, 3, added together, and the result of those three numbers we're going to call S, which probably stands for sum, right? Sum, three numbers summed together, there's a sum, and then afterwards that sum is then operated on to produce an average. So the sum is divided by 3 to give us an average, and then we return the average. So we have inputs, we have a processing, and we have an output, and that's what we're doing with our function. Now, I should say that the way we implement our functions, particularly in Python, is we tend to have multiple inputs, maybe 0 inputs, maybe 1, maybe 2, maybe 3, maybe 4. But the outputs that we have, the only choices that you have for outputs of a function in Python, for example, is you can have no output or you can have one output. You can't have multiple outputs. So that's, you have to keep that in mind as you're designing your functions if you're going to be implementing them in Python. We're using Python in this course at the end, so we'll do that. So here's some more notes about functions. The end of the function should have a return statement. We're going to look at a function in a minute. Now, when it says the return statement, well, what kind of statement? That could be in a programming code like Python, or it could be in the code that we're going to use tonight, which is called pseudocode. So we'll be using pseudocode at the end of this little bit of the lecture. In a pseudocode or in the other code of our function, we end the function with the word result, and the result may have a value associated with it. When we state result, so let me just, I'm going to put a function up here in, well, let's do this function. I'm going to put a function up here in Python. So the program that we're doing, we have a function which is called average grade. And it takes X, Y, and Z are inputs. So this is how I would create this function in Python. Def means function in Python. So what we would do is, this means those are our parameters, that's our inputs. Okay, and then we add them together. S is equal to X plus Y plus Z. And then what was it was average, was it A or something? What did they call it? They resulted. I don't know. Let's say A is equal to S divided by 3. And then we would say return A. So this is what it's talking about. The return. At the end of the function, you have a return. What the return does is that ends the processing of the function. If the return has a value after the return statement, then that will be the result of the function that will be passed out to the program. Okay, so I want you to have a look at this idea here. This idea is called a stack. The idea of a stack is we put one thing in, then we put another thing on, then we put another thing on, then we put another thing on. Then when we're finished, if we want to get back down to here, we have to remove this one. We have to remove this one. We have to remove this one. That's a stack. Now, a stack is the way that the computer memory processes functions. And so what that means is, let's say this is the main program, and the main program calls this function. That function, when the main program calls that function goes into the memory. So the memory of the computer has that function, and it has all of the variables that are associated with that function. That function processes. When it gets to the point where it says return, what it does is, if there's a value that function did that is going to be used by the rest of the program, well, that value goes back to the main program. But when that happens, as soon as it hits the return, the function is gone from the memory. You understand me? The function is only temporary in the memory. The main program stays until the program is finished, but the function only lasts until return. Excuse me, return. Once the return happens, that's the end of the function. Function's gone. Everything that was part of that function is gone from the memory. Does that make sense? That's important to the program. Otherwise, the program would get, the computer would just be making nonsense because there would be numbers all over the place that would be doing bad things in the program. I guess so. We've got a very clever, very successful way of managing the memory, and it's to use a stack. When we call the function goes into the memory. When we're finished, it comes out and it's gone. But we got something left behind, whatever was returned, right? The function returned a value, and that can be used. I hope that doesn't confuse you at all. It's not in the notes, So I can promise you it won't be in the test. I'm only saying it to you because I was hoping that it'll make you understand things better. If it doesn't, forget it. All right. It's an experiment. All right. So the function inputs the values. This is what I meant. That's what I meant by that weird example. The values of those x, y, and z only exist while the function is in the memory. Only while the function is being processed. As soon as we hit the return, poof, gone, right? So they cannot be called from the main function. The main's down here. It doesn't have access to this stuff, right? This stuff is living in its own little world in the memory, and it's only temporary. Their values are initialized during the function call. When we call them, we set them up. During the function, they might change, but they're all going to be gone as soon as we hit they're all going to be gone as soon as we hit the return. Now it says here, trace the execution of the previous program when the quiz is assigned a value of 80. So the program, this is this program where we, okay, the program was this, right? So we got three values, get x, get y. Oh, well, they called them assignment, right? This is assignment. This is test. And then there was get, after the assignment test, there was a quiz or something, right? So we get all three of those. Then we call this function, which is, you know, get the average or something. And then the function produces an output, and then we print the output. You guys like to see that in Python? I like to do it in Python. You like to see that? I mean, one day you're going to have to use Python. So, you know, might as well see it. Let's do that. Put on my glasses because I definitely type better with my glasses on. Okay, yeah, there it is. I was wondering why. So in Python, every time you start using Python, it'll show you this thing here. If you see this thing here, which has got those there, that means it's going to only process one line at a time. If you wanted to process well, Python always only processes one line at a time. But this one will really just take one line and ignore the rest. So you want it to work with the entire program that you write. So what you do is you go to File and you go to a new file. Then you get a different editor. It comes up like this. Okay, this is our average of 3 or something like that. Let's just, yeah, average of 3. I'm just going to call it that. So with this one, we've got a function. How we do functions in Python is like this. And that one's called average grade. And it's got 3 values, x, where's x on this? X, y, and z. Now in Python, every time you have a function, anything, which is a program structure, you always end it with a colon. So what that does is it brings you down to an indent. So what this was is we took the values and we had our sum is equal to x plus y plus z. And then our average was equal to the sum divided by 3. And then we returned the average. So that was too easy, right? So that's our, now, what I'm going to do with this is I'm going to number these lines. So we've done this kind of thing before, right? This is number 2. This is number 3. And this is number, well, I don't think that's not going to show up. So never mind. So now the next thing I've got is the main program. And I'm going to keep numbering the lines, right? The next line is going to be the number 4. But what we're going to do there is we're going to get the values. We've got quiz, lab, and test, right? So here we're going to say, what is the test? The test is equal to an integer of an input. And we'll just say there, we're going to ask the person to put test, and they will enter test when they see that prompt. And I'm too lazy to type that all out again. So I'm just going to do quiz is equal to, copy that. and change test to quiz. And then we're going to do it for lab. Now, you know that equal does not mean equal like in mathematics. That means is assigned the value. So what this means is, okay, Python, go ahead and get the input. Give this as a prompt to the user. The user is going to see test on the screen. And then they're going to, now I want to print this on the screen with the line numbers. So I'm going to put the line number here, right? This is line 4. So when I put a #4, that means to me, this is just code for me. Doesn't mean anything to Python. It just means to me that, hey, that's line 4. This is line 5. And this is line 6. So I can see what line. So this is I'm doing this as my trace. I'm using print statements to trace the program because that's the way I like to do it. All right, you know, because we know that other way, that takes time. So yeah, so I got my trace going here, I think. So what's happening in the main? We get those 3 values, then we run the function. We run the function. So what we say is we can have a variable called average, and we'll say that, well, average is going to do what? It's going to take these 3 values, test, quiz, and lab, and it's going to put them into the function called average grade. So we're going to, this calls average grade. Average grade is then called at this point, and the inputs are going to be test, quiz, and lab. Now, in this particular function, it doesn't matter what order that I put them in. But in if we had values that were quite a lot different, the order is important, right? The order is important. What this means, the way you should read this is just first, second, and third, because that's the way it is here, right? So this is going to become X, and this is going to become Y, and this is going to become Z in the function. First, second, and third. The order is very, very important. When you start writing your computer programs, be very careful of that order. All right, so we've got our average is equal to that, and then we just print it out. Now, what line of code is this? I'm just going to skip this. This line of code, average, so I don't need that. But I'll just say that this is line 7. And so this printout here is going to be from line 7, let's say. The average is. And then we're just going to say whatever average is. All right, let's run it, because I know you get tired of watching me write dumb computer programs, even though you have to do it at some point yourself. All right. Average of 3. All right, so the first line of code is line 4. What happened to line 1 and 2? I'll let you think about that and say, well, let's have a look. There is a, well, line 1 is nothing. But there's a line 2. So where did the program start? The program does not start in the function. The program starts in the main. The first line of code to be executed is in the main. This will only be executed when we call the function. Here we're calling the function. We call the function by saying its name and entering in the parameters. And whatever is going to be the return value is going to be set equal to average. So anyway, so the first thing we do is, so what were those numbers? It was 90. And there was, it doesn't matter, 89 and 60, let's say. So there's our 3 numbers. So that's going as we expect. There's line 4, 5, and 6. They're being processed. We haven't got to line 7 yet. So what will be the next thing that will be printed? The average will be printed at line 7. That's right. Oh, will it? You know what? What I should do is what I haven't done is I haven't put a print in here. I'm going to put a print in here. That'll be cool. Print. So this is going to be at line 2 and 3. And then we're just going to say, what are those values? S and A. So they'll be in that order. So S, no, all right, no, let's just do S and S and A. So I'm going to print those 2 values there from lines 2 and 3. Let's watch now. I'm gonna have to start this again. Yeah, I'll kill it. Run it. So the first line of code that's executed comes from the main here in line 4. And so we put our numbers in, got our 3 numbers. And look, the next line that's executed is this. So why do we go from here to here? What's happening is when we got to the next line, line 7, the instruction to the computer is go and execute the function called average grade and use these 3 inputs. We get the inputs, then we feed those inputs into that. And so the program control moves up to here. And these things start happening. And that's why we see this thing there, right? Is that cool or what? That is how functions work. So I hope that means something to you. Anyway, so why do we do functions? Well, this is why we do functions, because they make our programming better. Why do they make our programming better? Well, here's some reasons, right? So we use computational thinking. One of the things about computational thinking there is we do decomposition. Decomposition is breaking the problem down into smaller parts. Each of those smaller parts, if they meet certain requirements, they could be a function. All right, so if they meet, well, can they take inputs or not? Or can, is there some processing there that we can break off from the rest of the processing? So if we can do that, that would be a candidate for a function. Pattern recognition. Pattern recognition will tell us that when we look at the processing that we need to do, there's some stuff that seems to happen over and over again. Candidate for a function. We don't want to have to write the code 10 different times. Maybe we could write the code once and call it 10 different times. That would be better. Like with this average thing now, right? I could just, maybe I have to do this 10 different times. I got a little code there that just says, do that average. And it's a lot quicker. Now that also removes removes potential for errors, because if you had to write the same type of code out 10 different times, that's 10 times more chances to make a mistake in your typing out, in your creating the function. So so by creating functions, we do it once, we get it right, and we can relax, right? We know that that function works, and so we'll just use it as we need it. So there's that. The pattern recognition, the abstraction. I tried to make a point about that a few minutes ago. We want to have the most general purpose sort of functions that we can. So here we had a function. We're using it to make the average of the quiz, the test, and the lab, but we could use it for the average of any 3 numbers. Now, thinking a little bit more carefully, you could see that, you know what, I could get a more general purpose than that. I could make a little function that would just take however many numbers I want and give me the average of it. And it wouldn't be very hard to write that. And you could turn that into a function pretty easy. So all of these things are, I hope you recognize those as computational thinking sort of fundamentals. And computational thinking is about making our programming better. Now, about making our programming better, you may have heard the term software engineering. I don't know if you've ever heard that term. You can get a degree in software engineering. The idea of software engineering started to become important, I think, in the 1980s. The problem being that a lot of people were in the computing industry, and we had a lot of very, very smart people that had a lot of creativity writing computer programs, and they would kind of just do it in their own way. And so the problem with that is you got people would make very nice programs, but nobody else could do anything with them, right? Nobody could fix them. You know, you would have to take it back to the original person to do it, to get it fixed. I read an article by Scientific American. This is so long ago, but it exactly describes the situation. Scientific American talked about the opening of the American West. Scientific American, they're going to talk about America, right? And one of the things they mentioned was they didn't really get much traction going out west in the 16th, 17th, 18th century. And one of the reasons was about their weapons. So the weapons that they used were these muskets. And the muskets were created by artisans. So the artisans were really skilled people. They could make a musket, And the problem, and so it was done by an artist, if you know what I mean. So an artist expert. And the issue with that was that every musket was slightly different. Okay, and supposing a part on your musket broke and you're 500 miles away from the guy who made it, what are you going to do, right? You have to go back to the all right to that guy and get it fixed. Now, what happened in the middle of the 19th century is some factories started getting together and they got the idea of replaceable parts. So they started making the guns, and the guns would have, I don't know, maybe there's 100 parts in the gun, and each of those 100 parts in the gun would work with 1,000 other guns, right? So the gun factory could just make, just be making, each of those parts. Your part breaks and you're 500 miles away, you just go to the trading post guy and one's shipped out to you, you know what I mean? Because it's a replaceable part. Now that is engineering. What they did before was art. Afterwards was engineering, because they had replaceable parts that could be used in a sort of a systematic way. The idea is, how do we do that in our computer program? We have replaceable parts. The replaceable parts in our computer program could be functions, right? We could have functions that everybody could use. The other thing that we would have to do to make it engineering is we'd have to do it in a standardized way. So with those guns, for example, they were standardized. They standardized on certain bores. You had a 44 or 357. You didn't have a 682 or whatever. The bores were all standardized so that everybody was sort of reading from the same book, if you know what I mean, when they're making their guns or whatever, the factories. And so that you could have, so they were able to go from the muskets, which, you had to put, I don't know, you guys, I don't know, maybe I'm not connecting to you. You don't really care about guns. I don't know. No, but I read the article, right? All right. To be honest, when I was a kid in our house, we had, I don't know, 10 guns. Everybody had guns because I lived on a farm, right? So yeah, a little bit into guns. But they weren't handguns. They were, rifles. So, I had 22 rifle, 303 rifle, everybody had a gun because I lived on a farm. Well, I mean, we used to use the gun to shoot animals.
Have you ever used one?
Oh yeah. Yeah. Not so much for food, but anyways, you don't want to hear about that. Yeah. So the thing, yeah. So those modern guns that we had, I have experience with that. Broken part of the gun, and we have to go and order it and get another one. It's very, very easy to do. But as I said, if it was made by some expert back, 2,000 miles away, you basically have to throw the gun away. Yeah. So with programming, we got into that standardized thing. The other thing I want to say about the guns, the bullets, right? So you've got this gun and it uses this bullet, and the bullets are, all the bullets are the same size for that particular gun, right? You got 50 other people got gun like that. You can use their bullets. They can use your bullets. And it just, yeah, standardizing it makes it better. I'm sorry to use the gun thing. I hope that doesn't bother anybody. I don't know. It was an article in Scientific American. Anyway, so the idea being that we go from being artists to being engineers, right? To being engineers. With engineers, we care about precision. So we're going to get all of those measurements exactly the same. Every one of these things that we do is going to use the same way. When we do our computer programming, all of our functions are going to be set up the same way, right? All of our pseudocode, well, not our pseudocode, all of our computer languages, we use a particular syntax. And so we standardize, we have reusable code. All right, so how do we do this with a function? So you saw my function that I did here. We're going to talk about pseudocode in a minute, but we still have out here somewhere, I have my my Python code. So with the Python code, please notice the function has to have a name. And in pseudocode, we'll replace def with function. Then it has to have the inputs. Then we have whatever processing happens. Then we have to have a return value. All functions will be like that. This is what one looks like in Python. It would look like slightly different in Java or C or whatever. And we have this special thing that we use, which called pseudocode, to use it as well. So it has a name. The inputs come in on the header line, and then the result comes from the function. And so, for example, I used in that code this exact code. I think A takes the value of whatever is the output of that function. So going back to that again, yeah, can you see that? That's here. Average takes the value of the returned value of that function. This is what's called calling the function. This is where the function, we're saying, now I want to use that function. Here I declared it, now I want to use it. And I'm going to give these inputs and I'll take the output. That output will later be printed. As I said, with this function, we had 3 inputs and 1 output. Now, a function can have multiple inputs. It can have 0 inputs. You can run a function without any inputs. But you can have multiple inputs, right? 3, 2, 4, whatever. But you can only have 1 output or 0 outputs. That's the choices you've got for outputs in a Python function. All right, so that brings us to our concept of API. API, application programming interface. The idea here being is that a lot of people have used these, have produced these, I guess you could say, general user programs that you can download from the internet or that you can access from the internet or from other places. So they're programs that are meant for the normal public to use. Yeah, we've got 10 minutes. We'll try and get out of here before then. So programs that the general users want to use. Well, maybe the general users want to access some particular part of that to get some data out or something in a special way. And so maybe there's a function been written to do that. Maybe that function is able to be accessed by people who don't get the code. Because generally, so for example, we talked about compiled programs. Programmers that want to keep their program proprietary, they don't want people to take it and change it. And maybe they're selling it and making money out of it. What they'll do is they'll produce compiled code. And so that compiled code, you can't see it and read it. But you know it does something, but you don't know how it does it. So they're going to put some hooks there so that you can access some functions from outside of their system. You can access some functions and do some stuff with data inside their systems. That's called an API. There's an example of an API there where Twitter has an API so that people who maybe you're doing some research on Twitter, or maybe you want to, you're an active user of Twitter and you want to know something about some statistics of what's happening with a particular tweet. You can access the Twitter API and you can write a little computer program and get some information that would be useful to you. All right, so we're going to stop on that topic now. That's enough about functions. Let's talk about pseudocode. Pseudocode is one of the 3 ways that we show algorithms. Algorithms can be represented by flowcharts. They can be represented by English, structured English maybe, or they can be represented by pseudocode. Before we actually go writing the code. Now, why would we use pseudocode? It would be typical if somebody was designing an algorithm and they didn't know who's going to write the code. So they're writing the algorithm to be coded by somebody else, and they're giving that person the option of how they're going to code it. Maybe the person will decide, oh, I'm going to do this with the Java programming language, or I'm going to do this with the C# programming language, or I'm going to do this with the Python programming language. Pseudocode would be able to be the basis from which they could write in any of those languages. So pseudocode is not following strict syntax that we would use in a programming language. So it says it's informal. Now, the thing that it says here is that we're going to show you in this course a particular way of writing pseudocode. It's not the only way, all right? You could do pseudocode in another way and it would be okay. If it works for you, it's okay, really. If you can explain how it works, it's okay for you. But in this course, we're going to do it in a particular way. And so I would pay attention to how we do it, because maybe that's the way it'll be marked in the test if we ask you to do some pseudocode. So watch the conventions that we do here. So some of the conventions that we do for our pseudocode. This is pseudocode, CNAQ, winter 2022, right? At any other time, it might be different. But this is what it is right now here. This is how we do pseudocode. So for function, we're going to use like that. So I did it right or wrong. We're going to do, what do they call it? Upper camel case. So the first letter of every word is capitalized. Lower camel case for variables. So everything is lowercase except the first letter of second and third names in a word. Sorry, in a variable. For constants, everything is uppercase. We've done that before. When first time we do anything that has a variable, we need to define it. So this is something different than Python code. So here I used a lot of variables, so I didn't define them. This isn't pseudocode. This is Python code, right? In pseudocode, first time we use it, we're going to define what kind of variable it is. So here, this is an integer, this is a string, integer, and integer. Now, pseudocode is not the only thing like that. Java, C, you have to state what is the type of the variable first time you use it. So maybe that's why our pseudocode has to do that, because if you're programming in one of those languages, you need to state that. Python is, I think it's very easy to get started in Python. And so people look at Python and they'll say, oh yeah, that's not a real programming language, it's just too easy. But it's a real programming language. People develop very, I'm not going to use the word complex, very useful applications for running on mobile phones, for working with networks, for programming routers. You can do a lot of really, really good stuff with Python, and Python will integrate with your HTML and your PHP, etc. So it's quite powerful. It is a full object-oriented language, so you can build your classes. And I know this doesn't mean anything to you right now. You can build your classes and your objects, but you will learn about that later, and you'll struggle away with other programming languages like JavaScript. But you'll find that Python is quite useful. All right, so when we declare a function in pseudocode, we state that it is a function that we're creating, and we give the name of the function and the inputs. And because we haven't used them before, we have to say what is their data type. And this is a variable that's created inside the function, so we have to state that its data type is, and likewise there. Then we have our return. Otherwise, it kind of looks like my Python, right? The difference with my Python, as I said, I didn't have to declare what kind of data the variables were. By the way, the types of data, that's going to show up on your quiz this weekend, right? Because we have talked about it before. So when you have your quiz on Thursday, make sure you know what int is, what float is, what char is, etc. Okay, so some other things. When we do a selection, we do it like this. If this is the condition, this is the thing that would be inside the diamond. That's the condition. If then, now this stuff, now we always use curly braces. We use curly braces for every programming structure. So if this condition is true, so this means if true, we do this. This is the true stuff, right? That's how we do it in Python. I'm sorry, in pseudocode. This is the true. So what would this be? The else is the false, right? Or you could say this is the yes and this is the no. That's how we've been doing it on our flowcharts. So if you're taking your flowchart and you were converting your flowchart to pseudocode, this would be the diamond, right? And this is the true stuff, and this is the false stuff. Pretty easy, right? You could take this pseudocode and do the diamond, or you could take the diamond and do the pseudocode. Very easy. I hope that's okay. And we have another structure which is very useful, which I've used a bit in Python, but we haven't seen it in our discussion other than that. So here's a condition, and we've got this thing that says while do. So this is a loop. This is a loop. And what this says is, as long as this condition is true. Now, when I say this condition is true, that's interesting because this condition has got an inequality inside it. This symbol here means not equal to. So this is saying while the bill is not equal to 0. So this will keep going until the bill becomes 0, right? This is a sentinel loop, but this will be true as long as this is not 0. Because the whole thing has to be true for the while to keep going. Hopefully that's not confusing to you. You're gonna have to. That's our Boolean logic. What we want to know is that this whole thing together, the bill is not equal to 0. If the bill is not equal to 0, we'll say, well, that condition is true. If that condition is true, means that it's not 0. Does that make sense? Okay, so that's what I mean by that. So as long as it's not 0, we're going to do whatever's inside this curly brace. So the curly brace makes it easier for us because we can see where's the start of that curly brace, where's the end of that curly brace. That's all the stuff that's going to happen as long as the bill's not 0. And here, of course, how do we get the bill to be 0? Well, the person will enter an amount. This would have to be changed. So bill must be somewhere. We said that bill is a integer or something, or a float, and somewhere we said that sum was a float. If we enter that, and then when it becomes 0, we're done. I have said this before, but equal, when we use it in a pseudocode or we use it in a Python program or any other computer program, equal does not mean mathematical equal. What I try and say when I see that, and I'm talking to students like you, I try and say assigns the value or it takes the value. So like this does not mean that S is equal to X plus Y plus Z. What it means is take X, Y, and Z, add them together, and then that value is assigned to the variable called S. Or you could say S takes the value of X plus Y plus Z. Does that make sense? And the reason why I can't say it's equal to, because you can have this situation